Hello again. So you'll remember from our last video where we had to predict what our products are, that we ended up with a reaction where we took the aluminum plus the copper sulfate, and the aluminum comes in, kicks the copper out, so I end up with aluminum sulfate and some copper. And I've got it balanced here, and I didn't have it balanced in the last one. But what I want to talk about is, so that's all well and good, and I can write that, where I take some aluminum and put it in copper sulfate, and then I end up with aluminum sulfate and some copper. But what would happen if I put copper and some aluminum sulfate? Would I get aluminum and copper sulfate? Well, it seems silly that if this reaction makes it and this reaction simply turns it back around, which one of them really is right? Can they both happen at the same time? Well, some reactions, yes, they can both happen at the same time, but this isn't that kind of reaction. Only one of these two things happen, and the word we use when we talk about a reaction happening is spontaneous. And for our sake, the word spontaneous means will actually happen. Not all reactions are going to be spontaneous. Now, I will tell you real quick, acid-base and combustion reactions, COMBU, okay, are always spontaneous. We'll talk about why the acid-base ones are in a minute here. Combustion reactions deal with stuff burning, and pretty much anything made out of carbon and hydrogen is going to burn if you get it hot enough. So these two types of reactions are always spontaneous. These are the easy ones. If I hand you an acid-base reaction and I say, is this spontaneous? The answer is yes, always. There's no if, there's no, well, it's spontaneous. If this thing is here, or that thing's there, it doesn't matter. Acid-base reactions, combustion reactions, always spontaneous, but our single displacement ones, one of these two reactions is spontaneous. So we have to decide which one. And the answer is, we're going to need some more information from it, but the more reactive elements is going to be stronger. And so it's going to be able to kick the less reactive element out of its compound. Mm-hmm. So we need to know, if aluminum is more reactive, then it will be able to kick the copper out. And if copper is more reactive, then it'll be able to kick the aluminum out. So what we need is a list. What are the reactive elements? Okay. So I put in the reference folder of your classroom a list. It should look just like this, a reactivity series of metals from greatest to least. And you'll see aluminum is right here, whereas copper is way down here. So our aluminum up here is a lot more reactive than our copper is. What that means is that, yes, the aluminum can do this, the copper can't. So this reaction is spontaneous. If I put aluminum in copper sulfate, the aluminum will kick the copper out and produce aluminum sulfate and leave the copper hanging all by itself. But if I put copper in aluminum sulfate, this is a non-spontaneous. Nothing's going to happen. If this reaction does not occur, I can put I can put copper in aluminum sulfate and nothing is going to happen. Okay, so we have one last type. What about our double displacement reactions? Now you'll remember, again in the last video, that I had a reaction similar to this and I did not give you phase labels for our products. There's a reason for that. How we can tell if a double displacement reaction is spontaneous is that a spontaneous double displacement reaction it will produce a solid, liquid, or a gas. And for us, for these double displacement reactions, it's going to be that solid. Now you remember we got this liquid. That's why our acid-base reactions are always spontaneous, because they're really just double displacement reactions and they always produce liquid water. That makes them spontaneous. So we need these to produce a solid. Well, how do I know if those two things are a solid, or maybe they're both aqueous? And there's the other half of this reference we've got here. It's got this nifty table where I have positive ions, cations down the side, and anions across the top. And what these things stand for, the I equals insoluble, okay, which means that it's going to be a precipitate, which we know is a solid. Precipitate. Okay. The S means that it is soluble, and so it is going to stay aqueous. It's going to stay dissolved in water. Anything here that has an S, that compound, so aluminum bromide or a iron nitrate, okay, those things all dissolve in water. And since we've got a lot of water hanging around, those compounds are going to stay dissolved. But anything with an I on it, well, those compounds are not soluble. So no matter how much water there is, they're going to become a precipitate. So we need to decide. We've got now sodium nitrate. So we find our sodium. Oh, it's down here. Sodium is here. And this column, you can't see it right now, but this column right here is a nitrate. Okay, so this has an S. Again, that means it is soluble, which means we are going to put an aqueous phase label on the sodium nitrate. And then my silver chloride. Here's my silver. Oops, here's my silver. And my chloride, again, you can't see it, but is in this column right here. Okay, it has an I right there. That I stands again for insoluble, which is a solid precipitate. So I can put an S here. My reaction produced a solid, so this reaction is spontaneous. Okay, and then my second reaction, same thing. Well, I already know that this sodium nitrate is going to be aqueous, because it was last time. It's got to be this time too. So let's see if we can find the potassium chloride. My potassium is right here. And again, my chloride, if we can get it, okay, is right there. So this is a soluble substance also, which means that my potassium chloride is also going to be aqueous. And if you remember when we did our precipitate lab, we did a lot of these reactions where you drip two chemicals together and nothing happened. Okay, this is a non-spontaneous reaction, because I just took these ions, and just kind of shuffled them together and nothing really happened, right? So again, if it's double displacement, you watch for things that are going to be solid, things that are going to be insoluble in water. If it is a single displacement, you look to see if the chemical that starts off on its own and kicks out the other one is more reactive than the one that got kicked out. Okay, and then our acid-base reactions, our combustion reactions, always spontaneous, and just like before with our decomposition and synthesis reactions, I would never ask you for. There's no good way to predict those. Okay, so best of luck to you. See you later.